Hi, good afternoon, everyone. This is Trevor Pope with Tiffany Quinlan from Group 8. This week, we decided to take a look at what the ADT collection types are and understanding the various collections in that group as part of from the core competency list. I don't know about you guys, but when I started reading about these, it kind of almost blew my mind. So I had to really figure out what this was going. So hopefully what I talk about over the next few minutes makes some sense for you. I wanted to start first with some basic definitions review again. And the first thing is what is a collection? Those that have some coding background, you're probably more familiar with just arrays or variable arrays, which is really all that's what a collection is. It's a chunk of information or a component that has multiple pieces of information in it that share the same data type. In this case, in the SQL side, a collection can be an array or a list, with the primary difference being that array has a fixed number of elements, where a list can have any number of elements. What's important, though, is what kind of data goes in there. A collection typically will hold what's known as a scalar data type or a composite data type. Whatever that data type is in the collection is what's known as the base data type. And if that base data type is scalar, then it's what's called an attribute data type, or ADT. If it's an object type, then it's a UDT. And collections typically can be defined in SQL or PL SQL coding. And just as a side note, I don't know about y'all, but all these acronyms make my head want to explode. But anyway, so we digress. So moving on. When we're looking at the scalar data types and the object data types, I wanted to do a quick review as well as what those meant. Again, scalar data types are values with no internal components. There can be attributes associated to them, but they don't have anything else other than that what it is. So is it a number? Is it Boolean, i.e. true, false, null? Is it a character or a date time? So, and these are typically system driven. Object types, though, good way to think of these is it represents any real world entity. A student can be an object type, a bank account, a number, or a data structure. Object types typically in SQL are defined by the create type statement, and PL SQL is defined by the declare statement. So I'm going to primarily talk about the scalar data types because I wanted to focus on the ADT component of collections. The text has a good table, table 6.1, that really talks about SQL collections and associative arrays and how they work. But I'll review this here in a little bit as we go through. Starting off, the most basic collection at its basic level, and it's probably what I was most familiar with, is what is known as the V array or array. It can be, as you can see in the example, it stands for varying array, but the V array is the more accepted term for this component. As you see in the examples, in the SQL side, you would define a V array by using the create or replace and then type. And you define the size of the array with the number, so V array 3, and then what kind of array is it? In this case, it's a string array with varchar of 20 characters in length. Where in the PL SQL, you would still use the type, but it would be done in the declaration section. And it's still done the same way, where you give it 3 components of that V array and using strings of up to 20 characters. They're known as single dimensional. The V arrays, though, are defined by that number, that parameter after the declaration or or the statement that it's a V array, and it has to have an element number or a number of elements fixed to it. You can have null components or empty components or populated components or elements within that array, but the number of elements in that array is fixed, and it's sequentially a sequential index, or in this case they also call it densely populated. I'm guessing because it's a dense list from 1 to X, and it has to be like that. A table collection, on the other hand, is similar to the V array. It's also single dimensional. The primary difference is you don't have a limit on the number of elements. There's no max ceiling or maximum amount of elements you can put into it in definition. The trouble with that is a table, you can delete items from tables, and so if you need to edit them, you have to do it through the PL/SQL programming component to do that. A table will start with a sequential or densely populated index, but because elements can be deleted, it can end up leaving gaps in there. So looking at the quick example up at the top, on the left where it says create or replace, it's pretty simple or similar to setting the V-array component. In this case, you're just setting it as a SQL table, and it's a table of string characters up to 20 long. That line 2 there is the same. That's the same syntax that you'd also use in the PL/SQL side of things, and then line 3 runs or compiles it. On the right side of the screen there, where you've got the select statement, in this case, similar to the V-array, you can query a table collection by using the table function. So you see the table after the from, and then it's querying, or it's the SQL table that's been defined back in the earlier step. And then what it's also doing in the select statement is you're creating a pseudo column called Dundane, or however you pronounce it, and then that table creates an aggregate result set, which then when you print it, you see the column called Dundane, and with the 3 components or the 3 elements of that array, the SQL table array, with the names of the characters from the Lord of the Rings there. So that brings us to associative arrays. Associative arrays are, for all intents and purposes, a 2-column table. Column 1 is your index, and column 2 is your data element. It has the same base values as SQL collections. You can have scalar or composite bases. Difference here, though, is an associative array cannot exist in the database. It only can exist in the PL/SQL memory structure in the program. There's a couple of advantages, though, over the V-array and tables in using associative arrays. Because of its flexibility, you don't have to define the number of elements going into it. And as such, because you don't have to do that, to add to it is quite easy. If you're using a table element or a V-array element, and you want to add to that array, you actually have to extend it with an extend command. Whereas associative arrays, you don't have to do that. You also don't have to initialize them. You don't have to set them up and then go into them and use them. The associative arrays can be programmed as basically on the fly. And then the other side of that is the elements then can be added in any order in any position. You can, so the flexibility of the array here is quite powerful. And but if you don't know how to use it, I'm assuming it can also be quite confusing. But there's a couple of ways you define the associative array indexes. you can use what's called as a numerical index, or you can use a key or string index. And it's exactly what it sounds like. I mean, if it's a numerically indexed array, then you're going to use an integer or binary integer or a character, a varchar string or something with a size. Or in this case, you can also do string or key indexed, where the next one is a key type. You're creating the table of base type, whatever. But in this case, you're going to define what that key is. So to show that, though, I've got a couple examples that might make it clear. So this is coming straight out of the textbook. So I took a look through it, and I think I understand it. But the first example using a numeric index, you can see in lines 3 and 4 on the left-hand side there. Under example, for example 1, lines 3 and 4 define the local associative array. It's the type suit table. It's table of suit object, and you're using a binary integer for an index. So your array is now defined. Line 7 then declares the LV suit variable and ties it to the associative array. Lines 10 through 13 are assigning constructed instances. I mean, we're putting together the instance or the elements that's going into the array slot, if you want to call that. And it's assigning it to the numeric index of the array. And then the last bit is looping through where it would print it off. So that's a basic numeric index associative array. The next type would be your string or your key, your string index. So under example 2, it starts off similarly, except rather than calling the index in line 7, rather than calling the index a binary integer, it's calling it a varchar 2 of 5 characters long, 5-character string. Lines 13 through 25 then are assigning numbers to those string values. They're the string index values. So you'll notice that the index is a word, in this case, 1, 2, queen, all the way up to queen and king. And then it's assigning that index slot the number associated to that card name. And then line 28 then sets an entry point for the while loop. So it's saying set your current position as your first card. So it allows you to manipulate through those that index quite easily with those keywords at first. And then if you look down into the loop, you'll see the current is lvcard.next. And so it gives you the ability to increment through the array without necessarily needing a number to do that, like you do on typical for next loops, for example. So those are examples of the associative arrays using scalar data values. So just in summary, the V arrays and tables are collections. They're what are called schema level data object types. They can be SQL or PL/SQL driven, and they're constructed by calling the type name with some parameters typically. If the base data type is scalar, then the collection is attribute data types, or ADT. The V array is defined with a fixed size, and it always has to be, and it will have a sequential index. Your table collection is not size constrained. It'll start with a sequential index, but it potentially can end up with gaps if you delete anything. Associative arrays in this case, related to the ADTs, are first of all, they'll be PL/SQL only data types. They have to be programmed and run and stored in memory. They are assigned an element one at a time. If it's scalar, it's an ADT array. And because of the way the array is populated, the index populates with the element. So it's sparsely populated, but it can be an integer or a string, depending on how you set it up. So I really hope this made sense for people. It took a lot of head scratching and canoodling on my part to make sure I knew what I was talking about here. So I think I got it. Hopefully everybody else does. If I said something totally stupid or wrong, please let me know in the comments. Or if it's great, please let me know in the comments. Anyway, have a good one, everyone, and looking forward to seeing everybody else's.